Those of you that came in yesterday afternoon, we had kind of a fun lab. We'll be doing the same thing with those of you that are coming tomorrow. But one of the limitations of that activity, of that simulation, is I have to assume you're on cruise control in your car. I haven't yet taught you how to hit the brakes or step on the gas. And that's much funner. So let's talk about it. We call this acceleration. Acceleration, the fancy definition of acceleration, it's the rate of velocity change per second. You don't need to memorize that. In this section, though, we're going to be looking at constant acceleration. So Riley, I'm going to let you step on the brakes, or I'm going to let you hit the gas, but I'm not going to let you then step on the brakes harder or hit the gas more. We're going to accelerate at a constant rate, but then we're not going to change the acceleration. If we change the acceleration and it's no longer constant, you really need calculus then. That's just where our math skills don't help us too much. And I'll show you as the year progresses some really neat situations where, it's changing acceleration and we just don't have the math skills to handle it. But you can see why Isaac Newton invented the calculus, because he really wanted to handle situations like this. So our velocity change per second is constant. The units for acceleration are, if it's the rate of velocity change per second, anytime I tell you the word rate, what that really means is you're dividing by time. So put an S there for seconds. And who remembers what the units were for velocity? Yep. That's the symbol. I want the units. Well, if you look at your green sheet, do I have VAV equals something? What's the units for distance? By the way, this is how you can get away by deriving stuff. You can memorize it too. What's the units for distance? The units for, what do you measure distance in? Meters. What do I measure time in? So it's meters per second per second. Except we never say meters per second per second. With those two S's on the bottom, we say meters per second squared. Anytime you see a number with a meters per second squared next to it, that's an acceleration. In the same way, anytime you see a number with a meters per second next to it, you know it's a speed or velocity. Anytime you see a number with a meters next to it, you know it's a distance or a displacement. Acceleration is a vector. Direction matters because you can be speeding up or slowing down. But it's difficult to visualize or interpret its direction. And part of the reason is we tend to confuse it with velocity. The direction an object is moving and the rate at which it is moving are both related to the velocity, not the acceleration. You can be moving forwards and accelerating backwards. You can be moving backwards and accelerating forwards. You can be moving forwards and not accelerating, moving backwards and not accelerating. To determine the direction of the acceleration, we need to watch the object for a period of time and see how its velocity is changing. So we're going to do some kind of intuitive mental math, see if we can spot a pattern, and see if we can then generalize and go to an equation. Because mental math is kind of nice, but it's like counting on your fingers. We can do better. So we're going to have an acceleration of positive 1.25 meters per second squared east. You know what? Think of that as forwards. And I'm going to give you three different situations. In one situation, VI is going to be 0. In another situation, VI is going to be 2 meters per second east. And in the third situation, VI is going to be 2 meters per second west. And we're going to try and figure out how fast you're going after each second. So example A, we're starting out with a VI of 0 meters per second. O and S, what's our acceleration? What does this question tell me the acceleration is? If you're stuck, look up. Read that. You got it. Read that number there. In the brackets, where it says A equals, you got it. 1. Yes, loud and proud, loud and proud. We're accelerating, here's what that means. Every second, we're gaining 1.25 meters per second. Okay? So what did we start out at? After 1 second, how fast are we going to be traveling then? And instead of east, I'm just going to put positive 1.25 meters per second. After 2 seconds, how fast are we traveling? Positive 2.5 meters per second. See it, Owen? Speeding up. After 3 seconds, what if I want to know how fast we're going after 100 seconds? Do I need to calculate the previous 99? I hope not. File that away. Let's make it a little more interesting. Camille, in part B, I'm going to be going 2 meters per second. So I'm going to start out at positive 2 meters per second. Camille, what's my acceleration as a number exactly in the brackets there? Read it to me again. The same thing that Owen read. Yeah, don't overcomplicate this, folks. Owen was trying to go really deep, I know. What that means is I'm gaining 1.25 meters per second in the positive direction every second. So how fast am I going now after 1 second? 3 point? Yes. Can we recognize that there's always an invisible positive in front of a positive number? So I'm going to start putting the pluses. Camille, loading in the background. How fast am I going after 2 seconds? Can you figure it out, Camille? Yep. And after 3 seconds? Is she right? What if I want to know how fast I'm going after 300 seconds? Do I need to calculate the previous 299? I hope not. C is more interesting. C. Nick, can you read me how fast we're traveling according to part C? What would be a clever, easy way to represent west? We're going -2. So I'm going to scroll down a little bit. So I don't have all the numbers in front of me, but you got folks do. So we're starting out at -2 meters per second. But what's our acceleration, Nick? Positive 1.25. By the way, I think we're in reverse right now. We're going backwards. Okay? But which way are we accelerating? Forwards. How can that happen? That's really what's happening if you're going in reverse and you step on the brakes. Because you're slowing down, you're actually accelerating in the forwards direction. How fast am I going after 1 second? If I'm accelerating in the forwards direction at positive 1.25. Aiden. Negative 0.75 meters. So we're going backwards still, but not as fast. You visualize that? Okay. How fast am I going after 2 seconds if I'm accelerating forwards at positive 1.25 meters per second, meters per second squared? I'll put the positive in just to show that I noticed there was a sign change. By the way, here's what else that means. At time 1 second, I was going backwards. At time 2 seconds, I was going forwards. Somewhere between 1 second and 2 seconds, I must have briefly come to a stop and changed direction. I can tell you that from that information. There's a lot of information buried in there. After 3 seconds. And again, what if I wanted to figure out how fast I'm traveling after 500 seconds? I wrote here, there has to be a better way to do this. Please let there be an equation. And there is. So, whenever an object changes its velocity, by the way, please remember, velocity is a vector. It has both magnitude and it has direction. So you can accelerate by changing your speed or by changing your direction, or both. So you can be going at a constant speed, but if you're going around a corner, is your direction changing? Are you accelerating? Yeah, even though your speedometer isn't changing. Okay. Acceleration is defined as follows: change in velocity over change in time. Kiana, what's the symbol for change in? Do it. Let it go. Are you really coming back to this? Absolutely. I have a ferociously long memory. From who remembers? First of all, what's the symbol for changing? Delta V over delta T. But what's changing anything, Kiana, from your formula sheet? Used to be top right corner. Now apparently it's on the left, somewhere near the top. Okay, let's remember that. File that in your back pocket. Okay. Down here, I wrote the equation. We use A for acceleration. It's technically a vector. I forgot to put the vector symbols in. I did in the next one, right next to it. And since change in anything, Kiana, is final minus initial, this says VF minus VI over TF minus TI. However, because time is always a change in, we get a bit lazy. We stop doing time final minus time initial. We just put a T. Typically, you'll see it written like this. A equals VF minus VI over T. If you know your final velocity, if you know your initial velocity, if you know how long you were accelerating for, you can calculate the acceleration. Kiana, how many different variables are there in this equation? Kiana, look up. How many different variables are there in this equation? A, VF, VI, and T. How many different variables are there? How many different equations are hidden in this equation? I'm going to teach you how to derive them so you don't have to memorize them. You can choose to memorize all 4 equations. Don't. I'm going to show you a way that you can rewrite any equation in your head and you'll get good at it. Buy into it, please. Back up here. Symbol for acceleration, A with a vector. Often, and it's a vector, so let's circle the word vector. Often I'll just ask you to calculate the magnitude because I didn't give you enough information, but usually we'll assume positive means forward speeding up, negative means backwards slowing down. Or if we're looking at free fall Alessio, negative means down, positive means up. Units, meters per second squared. Meters per second per second. And you can kind of see it hidden in the formula because velocity is meters per second. Time is seconds. So velocity has the same symbol as speed, which is V. If we call the velocity at the start, when we start our stopwatch, as VI, initial velocity, and at the ending, we call it VF, final velocity, then the change in will be final minus initial. See how we're putting everything together? Good. And if we call TI, you know what? Time initial and time final, the change in would be that, but we just typically write it that way. Oh, good. I would have put this in our notes. Kiana, what's changing anything? Final minus. Yep. So, because velocity is a vector and it has 2 aspects to it, speed, magnitude, and direction, acceleration can occur if your speed changes. That's the one most of you are familiar with in a car. If the direction changes, going around a corner at a constant speed, or both, if you're speeding up and changing direction, going around a corner while speeding up or slowing down. In this unit in Physics 11, we'll be mostly looking at situation A. In Physics 12, we'll do an entire unit where we're looking only at situation B, called circular motion. When you're going around in a circle, your direction is changing, ergo you are accelerating. Therefore, you are accelerating. Example 2, a runner racing in a 100-meter dash accelerates from rest to a speed of 9 meters per second in 4.5 seconds. What's his average acceleration during this time interval? So this is the DFIC method that I use, and we're going to formalize it, I think, in the next lesson, so don't freak out. But for now, I would say to myself, Riley, what are they asking me to find in this question? Now, I think I did my rant last class, but Aiden, I'll repeat myself, trying to memorize pi or something like that, but you're back here. Math word problems are dumb. They're so contrived. They drive me crazy. I taught math for a decade and a half, but they're weak. Physics word problems are actually way easier. They are all going to be word problems, but the nice thing in physics is it's really easy to figure out what you're trying to find. because there's usually a phrase like what is, or find the, or figure out. Riley, what are they asking me to find? I'm going to write down A equals question mark. Why did I say average acceleration? I don't think runners accelerate at a constant speed, so I'm hedging my bets. We can't actually figure out the changing acceleration. Now, we'll find the average. Then I'm going to look through this question, looking for numbers and physics phrases, and I'm going to introduce you to one of your ding, 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 ding trigger physics phrases in just a few minutes. But what's that 100, Riley? What are the units next to it? So, time? No. What is it? Okay. And it's good units, so I didn't bother writing down the units. I like meters. What's that 9? So what is it's meters per second? What is it? Now, I heard somebody murmur, velocity. But now I'm going to say, which one? Is that the initial velocity or the final velocity? Because now we're going to have to distinguish. And from that, you're going to have to read the question and just get the time flow of it. That part, unfortunately, I can't teach you. It's just kind of figure out how it's flowing. Max. So I'm going to go VF equals 9. That suggests that there's a VI kicking around somewhere, and this is your first physics phrase that you always want to notice, and in fact, for the first while, we're always going to underline it. What's VI? Everybody underline the phrase from rest. That's a trigger phrase for me, and that means VI is 0. Riley, what's that 4.5? What are the units next to that 4.5? So, yep. Now I would say to myself, I'm looking for an equation that has to have an A in it and has these. To be honest, right now I've only given you one equation. It's this one. A equals VF minus VI over T. And you'll notice, Riley, that D equals 100, I'm not using it. They just threw in some extra information. Okay. Now we get to the plug and chug stage. Insert the numbers. Riley, this is why it's worth making this little list. What was VF? Yeah. 9. Yeah. 9. What? Nothing? Okay. Minus, what was VI? All over. I can do this in my head because it's really 9 divided by 4.5. It's going to be 2. But if you're using your calculator, Kiana, is this a fraction? Say yes. Is there more than one thing on the top? Say yes. Brackets around the top, or use your fraction button. Is there more than one thing on the bottom? Don't need brackets around the bottom. If we were doing sig figs, how many sig figs should I go to technically? 9.0, how many sig figs? 4.5, how many sig figs? So, I think because we're dividing, I would go to 2 sig figs. So, I'll go 2.0. What are the units for acceleration, Riley? Look up on your page somewhere. I think it's near the top of the page, is it not? I hope. No, what are the units? Not the symbol. Yes. No, but I'm doing that because your test is coming up this afternoon. Afterwards, I don't care about sig figs. I'll almost always go to 2 or 3 sig figs in my final answer. But why not stick some review in? What's your question?
I thought it would just be 2 because sig fig.
It is 2 sig figs. Oh, you mean you thought the answer was just, sorry?
I thought it would just be 1 sig fig.
No. Look at what I gave you. Look at the data they gave you. 9.0.
What 100 is 1 sig.
Didn't use it. Didn't use it. Okay, and the 0 is actually 0.000 because it's from rest. I know that's as many zeros as I need. Is that a big acceleration? You don't know enough yet. Okay, for what it's worth, it's about 1/5 of a g. So, turn the page. The SI unit for expressing acceleration is meters per second squared. Meters per second per second. So if an object is accelerating at 1 meter per second squared, its speed is increasing in the forwards direction 1 meter per second every second. If it's accelerating at 5 meters per second squared, every second it's gaining 5 meters per second of velocity. There is a second unit, and we use it sometimes because of cars. It's kilometers per hour per second. And the reason is your car speedometers give you your speeds in kilometers per hour. I hate it. I'm including it in this question, and then I won't ask it of you on a test or a quiz, but I'm covering it. So a UFO is reported as accelerating from rest. Everybody right now underline the phrase from rest. That's VI. To 680 kilometers per hour in a time of 2.0 seconds. What's its acceleration? Fatima, what's this question asking me to find? Yep. A, and by the way, we're going to start to abbreviate. So from now on, if you say A, I'll know what you mean. Or if you say VI, I'll know what you mean if it's asking us to find that. So I'm going to write down A equals question mark. Zeno, what does from rest tell me? Equals? Yep. No, VI from rest? 0. Okay. What's the 680? Not VI, but VF. Good. Good. Yeah. Yeah, but patience. So I'm going to write kilometers per hour, and T equals max 2 seconds. If we just crunch this, A equals VF minus VI over T with the only equation we currently have, we would get 680 minus 0 all over 2. And I can do this in my head as well. I don't need a calculator because it's 680 divided by 2. It's 340 kilometers per hour per second. You might use kilometers per hour per second when you're talking about a car's acceleration. This is gaining 340 kilometers per hour every second. So I wrote here, the speed of the UFO is increasing 340 kilometers per hour each second. This acceleration might be written in the form of 3.4 times 10 to the 2 kilometers per hour per second. Although kilometers per hour per second is not the officially accepted unit for acceleration, we often use it when we're describing the acceleration of an automobile, but I gotta be honest, I'm not a fan. I'm trying to remember, there might be one question in the homework where you're gonna do it, where it asks for it in kilometers per hour per second. Normally, I would say to you, convert this to meters per second. How would you convert that to meters per second? Something to do with a 3.6. What would I do? Is it times or divide? So if I wanted to, 680 divided by 3.6, that's what I would go divide by 2, and I get an acceleration of 94.4, which is high-ish. That's about 9 Gs, closer to 10 Gs. Humans can handle that for short bursts. Astronauts max out at about 8 Gs. So, good. Mr. Dewitt doesn't like that unit, but he tolerates it because of cars. Other ways to write the acceleration equation. Get the VF by itself. So let's write the acceleration equation. Let's leave the vector signs off because we're just going to do some algebra and we don't care right now. Equals VF minus VI over T. I want to get the VF by itself. I'll put a red dot above it just so I can see what I'm tracking. What side is the VF on? Left side or right side? Okay. What else is on there on the right side? What's the VI doing? There's also a T. What's the T doing? You notice how the T is dividing the entire right-hand side? if a t is dividing the entire right-hand side, what's that the same as doing to the t on the left-hand side? What's the opposite of dividing the right side by t? I'm going to argue that this equation can be written as AT equals VF minus VI. Same equation. Don't memorize it. I'll teach you how to derive it. I was trying to get the VF by itself. How would I get the VF by itself? How would I move that VI over? Add it. Why add? Because subtracting on the right-hand side. Is that okay, Ethan? We get this. There's an AT. There's a VI. You know what? My spacing is bad. Let me write it here. There's an AT. There's a VI added. And there's a VF left by itself. This is the equation that we'll use the most. In fact, I think if you look at your sheet, third line down, I think this is the first of the kinematics equations. Yes, I think. VF equals VI plus AT. Third line down or fourth line down or some. Yeah. Second line down? Oh, yeah, because I changed the sheet this year. So it's second line down? Okay. You'll probably end up memorizing this, but you don't need to. You'll memorize it because you're lazy. By the end of next week, you'll probably just, it's VF equals VI plus AT. Why do we like this one a little better than this one? No fraction. What if I wanted to get the VI by itself? Let's use this one as our starting point. What side is the VI on? What else is on the same side as the VI? An AT. What's the AT doing to the VI? How will I move the AT over? So the VF would just drop down like a domino. I would subtract the AT, and that would give me an equals VI, although do you mind, instead of writing equals VI, can I write VI equals, because we're used to seeing the thing by itself on the left? Remember, Kiana, I said there was 4 equations hidden in here? So, first equation, not my favorite. Second equation, my preferred version. Third equation. Kiana, what does it want me to get by itself now? T. Okay. I'll write down my preferred version because that's where I start out with. So VF equals VI plus AT. And I'll throw the vector notation in at the end because it just clutters things up along the way. What did you say I'm trying to get by itself? Prabnur, what side of the equation is the T on? What's going to drop down like a domino? The left side, the VF just drops down. I'll do that, and that way I've got kind of a reference frame of where stuff's going to go. What else is on the same side as the T? What's the A doing? So how will I move the A over? Remember that, remember that, remember that. What else is on the same side as the T? The VI. What's the VI doing? Adding, so how will I move it over? The real question is, which one do I do first? And the answer is, it's reverse bedmass. You'll do your adding and subtracting first, then you'll do your multiplication and dividing. So I'm going to subtract the VI. And don't write this down, write that down, write minus VI, and then look up, don't write this next bit down. In my Sesame Street imagination, I'll just imagine the AT dropping down there. Can you just imagine it there? How would I get the T by itself? How will I move the A over, Prabnur? What's the A doing to the T? So, divide the whole side by A, and that would be equals T, but do you mind, can I go T equals? And now I'll put my vector symbols in. By the way, you'll notice time is a scalar, so I never put a vector symbol on there because time direction doesn't make any sense. That was 5 seconds north. Doesn't make any sense. By the end of next week, you'll be doing all that in your head and far more complicated. If you can get to that point, you've cut your memorization down in this course by about 90%. So it's worth getting to that point. Kids, this seems to be a pretty strong class, aside from the fact that you didn't get the answer key joke. Kids get this at different rates, but I'm also doing you, this is called formula manipulation, if you want the fancy word. I'm doing you a huge fave in your math courses too. You'll find, anybody in math already this quarter? Math 11? Okay. When you get to rearranging the parabola equation, you'll realize I can do a lot of that in my head. Or I can show work because my teacher wants me to show work, but I know ahead of time what the answer is. I know I'm doing this right. So, trust me. Next page. All of us have a built-in accelerometer. You can feel acceleration in your guts, in your body. The only problem is it works completely backwards. Oh yeah. Your built-in accelerometer works backwards. If you're sitting in a car in the passenger seat at a red light and the driver steps on the gas, which way do you feel like you're getting pressed? But which way are you clearly accelerating? Your body can detect acceleration, but it always detects it backwards. Or, what if you're driving fast and the driver hits the brakes? Which way do you feel like you're getting thrown? But you're slowing down, which means you must be accelerating backwards. That's what slowing down is. How many of you have been on the elevator at Playland before? Or some similar ride? Okay. When it launches, which way are you clearly accelerating? Up. But which way do you feel like you're getting pushed? Which way does your stomach feel like it's going? So you feel like you're getting pushed down, but you're absolutely accelerating up. Your body has a built-in accelerometer. It just always feels it backwards. Oh, and when it shoots you downwards, you're clearly accelerating downwards, but which way do you feel like you're flying off? Up. Yes? So you feel like you're getting pushed up, but you're absolutely getting pushed down. There's another ride at Playland called the Music Express. I think it's right by the pirate ship. It's the one that goes in a circle really fast, and then the announcer, who wants to go faster? Fast. So when you're on that ride, which way do you feel like you're getting pushed? Outwards. Which way are you clearly accelerating then? Absolutely. When you're moving in a circle, trust me, you're accelerating inwards, not outwards. Your body is a backwards accelerometer, but that will work. I have yet to find a situation. So if you ever asked a direction, Ariana, about acceleration, if you can imagine riding that object, ask yourself, well, which way would I feel like I'm getting pushed? It's the other direction. Trust me, the acceleration is in the opposite direction. I know, but you're accelerating inwards. Because your body's a backwards accelerometer. No, I'm telling you, that's how it works. Why would it suddenly... First of all, the first four examples, yes, your body's a backwards accelerometer. Why would you think your body would somehow change when you're moving in a circle? That your body would somehow know, oh, we're moving in a circle, now we'll give them the correct direction for acceleration. No. Okay. By the way, the real question is not whether your body is a backwards accelerometer. Real question is why? Hold that thought. Example 4. What two words shall I underline in example 4 right now?
Rest.
From rest. I already made a mental note. VI is 0. I've got a data piece. From rest, it accelerates at 4.5 meters per second squared for 3.6 seconds, little under half a G. How fast is it now traveling? What's this question asking us to find? How fast? Is this question asking me to find A, T, VI, or VF? Oh, someone at the door? Pause the video. What are they asking me to find, Max? You know what? Let's write down VF equals question mark. I've written something down. It's no longer blank. I feel way better. And now I read the question looking for physics words and numbers at rest. Means what? VI is 0. What's that 4.5? Even if I hadn't given you that word, how could you tell it's an acceleration, meters per second squared? This is why you'll find you probably just start scanning for units after a while. What's that 3.6? I'm looking for an equation that has a VF, a VI, an A, and a T in it. And as a bonus, it would be lovely if the VF was by itself. Well, this is now second line on your green sheet. It's this one. VF equals VI plus AT. Also, Max, I did a check. All my units were good. VI is 0. A is 4.5. T is 3.6, which is what? I think I do this in my head. Sure I can. 4 times 3.6 is going to be 7.2. It's going to be 14.4. And then half of that's going to be plus 1.8. 14.4 plus 1.8 is 15.4. 16.2? Double check me. Guys, by the way, when I say try this, all of you are on your calculators right now. Every one of you. I'll call you out if I see you just sitting and waiting for other people. Is it 16.2 or am I off? Yeah?
Ooh.
Units. It's velocity. This is why you memorize units, because your final step, what did I just find? Oh, it's meters per second. And technically, we didn't get a directional component. Did we get a positive answer? Forwards, if they ask for a direction. So we'll be kind of sloppy with directions for a while until we get to more complicated questions. Example 5. Car is traveling at 110 kilometers per hour when it hits the brakes and accelerates with a magnitude of 8 meters per second squared. How many seconds will elapse before it comes to a stop? I like example 5. I like example 5. I like example 5. Example 5 is a nice question. Why would I say that? Did you hear me say it's going to be on a test, or you're the kind of student that tends to notice when your teacher emphasizes things? So good. Ooh. Peniel, what's example 5 asking me to find? So what variable is how many seconds? Velocity? Say no. Acceleration? Say no. So look at the equation. Which variable is seconds? Wow, that was amazing. I couldn't even see your lips move. I couldn't because there was... Yeah. Okay, wants us to find time. Why don't I like this question? First of all, I do like this question. I like this question. I like this. But just as a nerd, what don't I like about this question? That we're going to have to do a unit conversion. So, what is that 110? Yeah, no, what is it? Which one? That's the final velocity? I think it's the initial. So I'm going to go like this. VI equals 110 kilometers per hour. In our notes, let's show what we did. How do we convert kilometers per hour to meters per second? In your homework, if you go straight to your calculator without writing divide by 3.6 and just put an equal sign, I'm fine with that. In our notes, so when we're studying, we know what the heck we did. $30.5 repeating, yes? So I'm going to write 30.5. Since I'm not done yet, I want to avoid rounding off data midway through if I can. So I'm going to use my answer button later on, but for now, I'll write 30.5 repeating meters per second. What's that 8? How do you know it's an acceleration? And that's wrong. For a candy, can anybody tell me why the acceleration is not 8, Max? Why negative? We're slowing down. That's why I like this question. I like this question, because you can't just plug and chug. You got to think a little bit. I owe you candy later. I got VI. I got A. I need three things to find the fourth. I'm missing something. What's VF? How do you know? So another physics phrase or trigger phrase is the word stop. Underline it this time, but this is why I said to you, I'm looking for numbers and physicsy words. Peniel, coming back to you. What am I being asked to find? Can you find the equation that had the t by itself? You might have to turn back in your notes, but you do have an equation that we derived that has a t by itself. Is it on this page, or do you have to go back a page? Yeah, go hunting for it. I think it was near the bottom of page, I think. So t equals VF, good. Yep, all over. And I'll put the vector symbols in now, finally. Then you'll keep going. What was VF as a number exactly? Minus. What was VI? When we converted it to meters per second, I'm going to write 30.5 repeating. I'm going to hit my answer button on my calculator, and this is why all of you need to know where your answer button is. Divided by, what was the acceleration? -8. Now, here's the nice thing. If you missed that negative, because it's subtle, you'd get a negative time. Time is a scalar. Time cannot be negative. I saw a Star Trek episode where it went backwards. No, time cannot be negative. So if you ever get a negative time, go back, check your signs. You probably missed something somewhere. Peniel, is this a fraction? Say yes. Is there more than one thing on the top? Yep. Do you have the 30.5 repeating on your calculator still right now? Is that still sitting there? Did you go 110 divided by 3.6? Do that. You have to follow along, folks. Okay? So anytime, so right now, 110 divided by 3.6. And now you have a 30.5555. Yes? Or do you have a fraction? Just go 110 divided by 3.6 equals. Okay? What's on your calculator right now? I can't see from here. You have to tell me. 30.555 repeating? Yes? Okay, good. Ready? This is how we're going to type this, all of us. Is this a fraction? All of us except you, you poor... Do you have a new calculator? Oh, you got a new one! Good. Is this a fraction? Yes? Those of you that have the fancy schmancy fraction button, use that, but all of us are going to go, is there more than one thing on the top? Say yes. Bracket. 0 minus, and then you want to find your answer button, because that will actually type in 30.5 repeating, and it won't round off. So where is your answer button? This is your chance to figure it out. If you don't know where your answer button is, I can come and help you find it. Now is your chance to ask. Did you find it? Good. Have we finished the top? Have we finished the top? Close off the top. Good. Divided by. Is there more than one number on the bottom? No. So do I need to put brackets around the bottom? No. -8, and now hit equals. I'm going to be fussy. I'm going to teach you how to use your calculators for maximum bang and minimum buck. Did you all get 3.81? How about 3.82?
Yeah.
Aiden, question. Hang on, almost. Units, time.
Seconds.
Thank you. Units, time, seconds. Well done. Yes?
Like I just did, like before you did it, I was just trying to see if I could do it right.
Yeah.
And I just went through 3.5 repeats times -1, and then that just gave me the answer. Just put it into minus that.
Yep. There's shortcuts, and as long as you're always getting the right answer, go ahead. Any of you been in a Tesla? Ooh. I took one for a test drive a couple of years ago. When you were in it, did they punch it? Yeah? I mean, they accelerate like you wouldn't believe.
It's so fast.
Electric motors are unlike gas motors. They have full acceleration. When you step on the gas, you have that, and there's that delay, right? Electric motors have full torque instantly. It's pretty impressive. So these numbers are fairly accurate. The new Tesla Model X can accelerate from rest. All of us are going to underline the phrase from rest to 30 meters per second in 3.2 seconds. What's its acceleration? Ethan, what's this question asking me to find? A equals question mark. From rest, what's that telling me? What's 0? No, what's 0? VI. By the way, if you ask me a question and you haven't listed your data, I'll walk away. Mr. Duke, how do I do? Have you defect yet? No? I'm not going to help you. What's that 30? I'm asking Ethan. I like your enthusiasm. And then little Simba's now, okay, there you go. Little Simba's staring at you now too. How do you know? Meters per second. So I know it's a velocity. And then the time flow of that part I can't help you with, just the time flow of the English grammar of the sentence, right? What's the 3.2? How do you know? Yep. And were all of my units happy joy units? Good units? Yep. I just do that on the fly. I'm looking for an equation that has an A, a VI, a VF, and a T in it. There is one, and I think in one of them the A is by itself. What's my equation, Ethan, my friend? I'll give you a hint. A equals. This is how we started out this lesson. We defined it as the change in velocity, final minus initial, right, Kiana? Divided by the change in time, but we're lazy. Time's always a change in, so we don't do time final minus time initial. It's going to be 30 minus 0 divided by 3.2. Can I do that one in my head? Maybe. It's going to be 15 divided, maybe not. 15 divided by 2, so it's going to be 7.5 divided by 2, so it's going to be 3.25 divided by 2, so it's going to be 1, nope. Is this a fraction? Brackets around the top. Now, what's 30 minus 0? I could probably have gotten away with just going 30 divided by 3.2. You typed it in already, right? Folks, if you're not typing this in, I'm going to call you on everything. You have to follow along. What'd you get? 9.375. I'll call it 9.38. Units. It's an acceleration. What? That's not units. That's the symbol. Units. It's an acceleration. Okay? And I'll be doing this so often, you will have these memorized by the end of next week. Meters per second squared. Put your pencils down, look up. What's your homework? You're going to have to do these, I think, on a separate piece of paper. Okay? Ah, man. I'm going to skip number 1 because it's got kilometers per hour per second, and I hate those units. But number 2 is good. Number 2, I want the answer in meters per second squared. I gave you the speeds in kilometers per hour, so you have to convert them. How do I convert kilometers per hour to meters per second? I don't remember. It's something to do with a 3.6. Can't remember. 3 is good. 4 is good. Those numbers are accurate if you want to figure out what Usain Bolt accelerates at. Now, that's going to give him an average acceleration because, again, if you're running, your acceleration changes. You're accelerating your fastest after a couple of strides, and then you start to max out. Number 5. Number 6, I'm going to put a star next to. I haven't explained it yet. I'm introducing the concept of G's, and I'm going to do a whole lesson on it, but I can't resist looking at the woodpecker. The number of G's that it takes on its brain is crazy. In fact, they're looking at its brain and trying to apply some of that to crash helmets. Okay? As a reference, On the elevator, you typically get about 3 Gs vertically. I've gone on it with an accelerometer. On the scrambler, you typically get about 4.5 Gs laterally. That's sideways. 2 is good. Sorry, 7 is good. 2. So California Screaming. How many of you been on California Screaming? It's now called the Incredicoaster, but okay. So that the Tesla accelerates a little faster than that. So if you've been on there, that's why you can say, oh, now you know why they were reacting that way. So it's even more intense than that. 7 is good. Keep 7. 9 is good. 10 is good. 11 is good. 12 is good. I'm probably going to assign almost all of them. Yeah, 13 is good. 14 is good. Okay.
So we don't need to do 6.
I skipped number 1.
6.
No, 6 try. I'm just saying, this is my way of saying, I told you, I think, I'm not going to explain everything in the homework to you. I want to see if you can have the aha moment on your own. And if not, I'll talk about that Wednesday. Do I see you Friday? Monday. So this homework here, you can also work on Friday afternoon. If you want to come by Friday afternoon, I'll be here. If you have any questions, I'll be here as well. Okay? It's 9:50. I'm going to give you about a 15-minute break so you can kind of veg. Then you can start the homework, but I'm also going to start a tiny bit of the next lesson to introduce all 4 kinematics equations to you, and then we'll also do the quest.